Hi, in this video we will talk about only one sentence. Linear equations in x, y, and z describe a plane in R3. This is basically the first sentence of section 1.3 and we want to understand it by details. Okay, let me start with breaking down this sentence into the pieces to be understandable easily. So first thing is that what is a linear equation in x, y, and z? Well, equation is equalities of two expressions. But what does it mean, linear equation in x, y, z? So it means that it is an equality of two expressions in variables x, y, and z that have both of the expression have degree 1 in x, y, and z. Well, more precisely, we mean that we can write both expression of this form. There is a constant 1, 2, 3 any number times x, then another constant times y, then another constant times z. So two expressions in this form are equal. That equation is called linear equation. For example, expressions for x plus 2y minus z, or x minus 2z are linear. Well, you may say, what happened to the y in the second one? Well, this is the coefficient of y, the constant for y in the second one is 0, basically, plus 0, y. And expressions like x times y minus z, or x squared plus 2y minus 1, or root x plus 2 z minus y are not linear. So we have to, our equation has to have this form. In particular, what we need to know about the equations in x and y, in particular, linear equations in x, y, and z can be written as a number times x plus another number times y plus another number times z equals another number for some constants a, b, c, and d. Well, yeah, with different constants, so you will have that equation. So this is the form of the equation we will call the linear equation. We know that These kind of equations are going to describe a plane in R3. But there is a question that how an equation in xy, how is the equation in xy is related to points in a plane in R3. So how is an equation in x, y, and z related to points of R3? Well, the point is that every point in R3 has three components. Yes, so let me just write every point in R3 has three coordinates. Yes, so one would be, let me just write x0, y0, z0. Now, if you have an equation, then there will be two possibilities. The point satisfies equation or not satisfy equation. Satisfying means what? Means that if we put the first coordinate for x, so if you take the equation and you put the first coordinate for x, the second coordinate, plug in the second coordinate for y, and plug in the third coordinate for z, then this equality holds. So plug in those ones, and if it holds, then if equality holds, then we say it satisfies the equation, the point satisfies the equation. Equality does not hold, we say the equation does not the point does not satisfy the equation. Let's just do an example. Check if the given point satisfy the equation 2x minus y plus z equals to 2. And we have actually 2 points. Our first point is 1, -2, and -3. And then the second one is 2, 1, and -1. Okay. Satisfy means what? Means that plug in 1 in x, y, -2 in y, and -3 in z. See if the equality holds. Okay, let's do this. 2 for x, you plug in 1. Minus for y equal plug in -2, and for z plug in -3. This guy is 2 2 plus 2 minus 3, which is equal to 1. The equality says that this expression is equal to 2, but what we found was 1. That means that the point 1, -2, -3 does not satisfy the equation. So you plug in, if the equality holds, satisfied, does not, then not. Well, how about this other one? Okay, so we need to plug in the first coordinate in x, second coordinate in y, the third coordinate in z. So 2 times 2 plus, minus y. You see there is a minus sign here. So minus y is 1 plus z is negative 1. This gives us 4 minus 1, and it is equal to 2. Yes, when I plugged x, y, z in the left-hand side, I got the right-hand side. That means that 2, 1, negative 1 satisfies the equation. Okay, so while there are points on the R3 that satisfies equations, some point does not. But how this defines a plane? So how does an equation define a plane? Well, here's the thing. You put all the points in R3 which satisfy the linear equation, you put all of them together. So if you have let me just draw an equation, something like that. You have been given an equation, linear equation x, y, z. Find all the points which satisfy that equation. If you do all of those ones, and well, there will be infinitely many of them, and you put all of them together, what you will notice that is that, okay, all of those points together form a plane in R3. That's how an equation, a linear equation in R3 defines a plane. So all the set of all points in R3 which satisfy the equation form a plane. Well, that's how points satisfying the equation you put all together, that will give you one big plane. And the last question is that, okay, so if an equation is there and you have a point, you can check if that point satisfies the equation or not. In other words, if that point is on the plane or not. How about how to find a point on a plane given by an equation? Well, basically, you see here in this example, there is an equation and there's a point. I can check, plug in the point there, and tell you if it is satisfying the equation or not. In other words, if it is on plane or not. How about now an equation is given like 2x minus y, 2x minus y plus z equals to 2. And then the question is, find a point on the plane. Well, there are infinitely many points on the plane, but give me one way. Give me an algorithm that using that I can find points on the plane given by this equation. And that is a very easy thing to do. Plug in any number you like for x, or for two of the variables of the variables present in the equation. For example, in this case, I can say, well, just random, x to be 10, y to be negative 5. Then you plug in these guys in the equation. You will get 2 times 10 minus negative 5 plus z is equal to 2. Then you see that there will be an equation for the third variable. Here in this case, z, this will be 20 plus 5 plus z is equal to 2. That means that z equals to 2 minus 25, which is negative 23. Well, you do plug in any number to two of the variables present, then solve the equation, the obtained equation for the third variable. In other words, here we did that, and then what we find is that the point that we found has x, the first coordinate 10, y, the second coordinate negative 5, and z, the third coordinate negative 3, is a point on the plane. So you plug in any two of the variables present in the equation and then solve it for the third one, and you will find all coordinates of a point satisfying the on the given plane. Okay, so we learned what is a linear equation in XYZ, how an equation is related to points in R3, and how they define a plane, and how we can find points using the equation.